Hello, so good morning all. So today we will start the unit DC motor. So DC motor, so motor is nothing but it is a one device so which converts electrical energy into mechanical energy, means rotational energy. The electrical energy is converted into rotational energy. Motor, electrical motor which works on electrical supply. Input is electrical and output is mechanical. It is nothing but a rotating energy. So electrical energy is converted into magnetic energy by using that electrical motor. So for that we are using electrical supply. So if we provide DC supply to the motor as a input, then it is called as a DC motor. And if we provide AC supply as an input, electrical input, then this such motors are called as a AC motor. So today we will see the concept of DC motor which works on DC supply only. DC motor which works on DC supply, means DC electrical energy is converted into mechanical energy. So one by one we see, first we will see some working principle of DC motor, then we will see the construction, then we will see some parts of types of DC motor, and then we will see the applications of DC motor. So first we will see the working principle of DC motor. So DC motor working principle, you should remember that working principle of DC motor. So working principle of DC motor says that, state that if current carrying conductor placed in the magnetic field, it will experience a force, mechanical force. So this is the simple principle of DC motor. So principle of DC motor is, if current carrying conductor, if suppose this is the current carrying conductor, suppose this is the conductor, if this current carrying conductor placed in a magnetic field, if we place this current carrying conductor in a magnetic field, means suppose this is the magnetic field, suppose this is the this conductor, suppose this is current carrying conductor. So suppose this is the current carrying conductor. So this supply, this notation indicate that dot inside the circle indicate that the current flows from both side to your side. So this is the direction, it indicate direction, this middle dot indicate the direction of current. So suppose this is the current carrying conductor and we are seeing the cross sectional view, current carrying conductor, long straight conductor. Suppose this is the conductor, long straight conductor placed like that, means if this is the cross sectional view, but conductor is this is a long straight conductor, and if this current long straight conductor carry current in this direction, and if you are see that conductor from this direction, this side, so it will look like this, it will look that like this side view of this conductor, current carrying conductor. So it will see in circular manner, and this dot indicate current flow from both side to your side. So this is a symbolic representation. So current flows from both side to your side, and this is a long straight conductor, current carrying conductor, and you are seeing a side view of this conductor. So this according to this principle, if we place this current carrying conductor in a magnetic field means, for there are, we see in unit number 2 magnetic circuit, there are two types of magnets. One is the permanent magnet and second is the artificial magnet, or it is also called as a temporary magnet. So temporary magnet we can create. So suppose there is a permanent magnet or magnet, if we place that current carrying conductor in between a magnet, suppose this is the magnet, suppose this is the north pole, suppose this is the north pole, and suppose this is the south pole, this is the south pole, north pole and south pole. So in between north pole and south pole there is a magnetic field. We know that magnetic flux will travel from north side, north end to south end. So this is the direction of magnetic flux. So in between this north pole and south pole there is a magnetic field or magnetic flux, and direction of magnetic flux is from upper side to lower side. So this is the direction of magnetic flux. Means in simple, we placed this current carrying conductor in a magnetic field. So this is the current carrying conductor, and in between north pole and south pole there is a magnetic field. Magnetic field means we placed that conductor in between a magnetic field. So according to the principle, working principle of DC motor, if we place this current carrying conductor in a magnetic field, then it will experience a force. It will experience a force. Means either this conductor will move to a right side or to a left side. It will move to the right side or left side. It will move. It will move. Means the force will exert on that conductor and it will move either left side or right side. So due to the principle of DC motor. So remember that principle. When a current carrying conductor placed in a magnetic field, it will experience a force. It will experience a force, and that conductor will move either right side or left side. So that direction of that movement will be decided by Fleming's left hand rule. So there are two rules: Fleming's left hand rule and Fleming's right hand rule. So Fleming's left hand rule is applicable for motor, electrical motor, DC motor, and Fleming's right hand rule is applicable for generator. So remember, right hand rule is for generator and left hand rule is for motor. So that Fleming's left hand rule says that if we stretch these three fingers mutually perpendicular to each other, if suppose these three fingers is nothing but this is called as forefinger or index finger or first finger. This is called as second finger, and this is called as a thumb. Means this is the first finger, this is the second finger, and this is thumb. This first finger is also called as forefinger or index finger. This is the second finger, or this is also called as middle finger, and this is a thumb. So if we extend these three fingers mutually perpendicular to each other, so in between these three fingers, suppose there is a 90-degree angle. Means these three fingers are suppose mutually perpendicular to each other. Then in this case, if this first finger or forefinger or index finger, if first finger indicate the direction of flux, in this case, if first finger indicate direction of flux, if second finger indicates the current flow from this conductor, then thumb indicate the force, movement of that conductor. So here in this case, what is the magnetic flux direction from upper side to lower side? This is the direction of magnetic flux. Means if first finger indicate direction of magnetic flux, if second finger indicate direction of current, so current flow from this conductor, current flow from both side to your side. So this is the direction of current. So if second finger middle finger indicate direction of current, so current is from both side to your side. So this is the direction. Then thumb indicate direction of force. Means this conductor will move towards right side, not a left side. So this conductor will move to the right side. So this is the direction of movement. Means this conductor will move to the right side. Means here electrical energy, that is electrical current carrying conductor, electrical energy is converted into mechanical energy, force or rotational energy. That force will exert on this conductor. Means this conductor will move either right side or left side. So according to Fleming's left hand rule, this conductor will move towards right side according to Fleming's left hand rule. Because in this case, the direction of flux is this, direction of current is this, middle finger, and the direction of movement, the conductor will move to in this direction. The thumb indicate direction of movement. So remember Fleming's left hand rule. If first finger indicate direction of flux, if second finger or middle finger indicate direction of current, then thumb indicate direction of force. So this conductor will move towards right side due to Fleming's left hand rule. So here, if we place another current carrying conductor here, suppose, so another current carrying conductor is here, and the direction of current flowing through this conductor is this. This is the direction cross, which indicates current flow from your side to both side. This is the indication. Cross indicate current flow from your side to both side. Means current is going, and this dot indicates current is coming from both side to your side. Current is coming, and this is indicate that current is going from your side to both side. So if the conductor is current flow from your side to both sides, so this is the direction. In this case, also this current carrying conductor placed in the magnetic field, so it will experience a force, movement, either left side or right side. So what is the direction of movement, left side or right side? Apply Fleming's left hand rule. Similar, apply Fleming's left hand rule. So Fleming's left hand rule says that if This first finger indicate direction of flux. So here also from north pole to south pole, this is the direction of flux downward. If middle finger indicate direction of current, so in this case direction of current is from your side to board side. So this is the direction of current. Then thumb indicate direction of force. So in this case, this conductor will move towards left side. It will not move to right side. It will move to left side due to Fleming's left hand rule. So apply. This indicate direction of flux. This indicate current. Current is away. And this, in this case, this thumb indicates direction of movement. So this conductor will move towards this left side like that. So this conductor, due to Fleming's left hand rule, this conductor will move to right side and this conductor will move to left side. Means here electrical energy, this current carrying conductor, electrical energy is converted into movement. Movement is nothing but a mechanical energy. So here if we place these two conductor on one single drum or cylinder, drum. So this is suppose a drum or cylinder. Suppose if we place these two conductors on the circumference of this drum, in this case, what will happen? And suppose if we connected is one bearing here, shaft here like that. So this is a cylindrical drum, circular drum, cylindrical shape. And we place that conductor, two conductor, this conductor and this conductor at the outside of this drum, suppose, at the circumference of this drum. Then what will happen? At the surface, if we connect that drum, that conductor, surface of the drum, at the surface of the drum, if we connect a conductor, then what will happen? This conductor will move this side and this conductor will move this side. So this drum will rotate in clockwise direction. This drum will rotate in clockwise direction because this movement will convert into circular motion. So that drum will rotate in clockwise direction because this conductor move to this side and this conductor will move to this side. So that's why this drum will rotate in clockwise direction. Due to the principle of DC motor. If current carrying conductor placed in the magnetic field, it will experience a force, and that direction of force will be decided by Fleming's left hand rule. Due to this Fleming's left hand rule, this conductor will move to the right side and this conductor will move to the left side. Due to that, this drum will rotate in clockwise direction. Means here electrical energy is converted into rotational energy. So this is simple principle of a DC motor. Simple, very simple. So due to that principle, this drum will rotate. So here one interesting fact is this in motor there are two main parts. One is the stator, stationary part, and second is the rotor, which is the rotating part. So stator is the stationary and rotor is the rotating part. So here this part is rotating actually. So this part is called as the rotor of the motor. This is the rotating part. And this north pole and south pole is the stationary part. So this north pole and south pole is nothing but a stator of the motor. So if we see the construction of DC motor, then construction of DC motor is like that. This is the circular DC motor. Outside part of the DC motor, it is called as a yoke of the DC motor. Outer part of the DC motor. Outer part of the DC motor. This north pole and this outer part, yoke, is called as the stator of the motor, and this middle part is called as a rotor of the motor because this is a rotating part. So here in the motor there are two main parts. One is the stator and second is the rotor. Rotating part, stationary part. So in stator, due to the stator, the magnetic flux will produce due to this north pole and south pole. And here in rotor, these are the current carrying conductor. So this rotor is also called as armature. This rotating part is also called as armature of the motor, and this is stationary part. It's called as a stator of the motor. So this current carrying conductors are also called as armature conductors. Current carrying conductor is also called as a armature conductor because these are the placed on the surface of the armature. So this is called as a current carrying conductor, or it is also called as a armature conductor, and this is rotating part is called as armature. Armature. And this such type of current carrying conductor, there are n number of current carrying conductor may be placed on the surface of this armature, n number of conductors, and always upper conductor, there are n number of conductors are connected on the armature, n number of conductors, many, it depends. So always upper conductors, current direction of upper conductors is incoming from both side to your side, and always current from lower conductor is away from your side to both side. Lower conductor, current direction is from your side to both side, lower conductor, and at upper conductor, current direction is from both side to your side. Incoming, upper current is incoming, and lower conductor current is outgoing from your side to both side. So due to that, and due to Fleming's left hand rule, all upper conductors are moved towards the right side, and all lower conductors are moved towards the left side. So that's why this armature will rotate in a clockwise direction. Due to that, because current in upper conductor is from both side to your side, and current is in lower conductors are from your side to both side. So that's why all upper conductors, due to Fleming's left hand rule, all upper conductors will move towards the, here you can apply like that. You can apply Fleming's left hand rule like that, So all upper conductors, thumb indicate the direction of movement. All upper conductors will move towards right, and all lower conductors will move towards left. So this armature will rotate in a clockwise direction. This armature will rotate in a clockwise direction. So here, next part is this north pole and south pole. If this is a permanent, there are n number of some types of DC motor. So first type is called as a permanent magnet DC motor. So here in this case, this north pole and south pole, if these are permanent, then such type of motor is called as a permanent magnet DC motor, because these poles are permanent, north pole and south poles are permanent. So such type of motor is called as a permanent magnet DC motor, because here permanent magnets are used. Another type of DC motor is the separately excited DC motor. Means for that, in that case, this is not a permanent. This is a temporary or artificially. We can use that artificial magnets also. Artificial magnet. How we can use that artificial magnet? Artificially, how we can create that artificially? That north pole and south pole artificially. Temporary magnet, electromagnet. So for that purpose, we can connect one winding here. We can connect one winding like that. This is the suppose winding. If we connect a winding here and here also, if we connect a winding, and if we provide supply voltage source, DC voltage source, positive, negative, because DC voltage source, because this is the DC motor voltage source. If we provide DC voltage source to this winding, then due to this DC voltage source, current, some amount of current will flow through this winding. Due to current flowing through this winding, what will happen? Magnetic flux will produce inside that winding. Magnetic flux, magnetic flux will produce, and that magnet, due to that magnetic flux between this pole and this pole, there is an electric field, and due to that electric field, this current carrying conductor will move. So like that also we can create an artificial magnet. So for that purpose, we need a separate DC voltage source for this winding. We need a DC voltage source. Due to that DC voltage source, current will flow through this winding, and due to this current, magnetic flux will produce, and that magnetic flux, direction of magnetic flux will be given by right hand thumb rule. The right hand thumb rule, it states that if we hold this in our right hand, if finger indicate direction of current flowing through this coil, then thumb indicate direction of magnetic flux. Means current is, suppose current flowing through this coil is, this is the current, finger indicate direction of current, then thumb indicate direction of force, the direction of flux. Means this will act as a north pole, and here this will act as a south pole, because the current flowing through this coil, is this. This is the direction of current. Then thumb indicate direction of magnetic flux. Means magnetic flux will create in this direction, and this yoke, that the magnetic flux will return, or magnetic flux will complete path through this yoke. This is the this magnetic flux will complete. Some half number of magnetic flux will go in this direction, and another remaining half number of flux will go in this direction through the core or yoke. This is called as yoke. So this is the magnetic flux. Magnetic flux will complete path through the yoke, outer part of the motor. So this yoke is generally made up of cast iron. So due to that property of that iron, the magnetic flux has very low reluctance in iron as compared with air. So that magnetic flux will not go through the air, that will go through this cast iron material, because it has a very less reluctance, magnetic opposition as compared with air. So all magnetic flux, 50% magnetic flux will go in this direction and complete path, and 50% magnetic flux will go in this direction and complete the path. In the yoke, from the yoke, that magnetic flux will complete the path. So this is called as yoke. This is called as north pole, south pole, and that north pole and south pole, due to that north pole and south pole, magnetic field will create. Due to this winding, magnetic field will create. So this winding is called as field winding. This winding is called as field winding, because that due to that winding, magnetic field will create. So due to that field winding current, magnetic flux will create, magnetic field will create. So this winding is called as a field winding, and the current flow through this coil. Due to we need another supply voltage source to flow the current from this conductor. So that supply, how we can give that supply? So for that purpose, we required another DC voltage source to current carrying conductor. Current should flow from this conductor also. So that is the electrical energy. That energy will convert into mechanical energy. So due to that electrical current, we need one separate DC voltage source. So due to that DC voltage source, some amount of current will flow through this conductor. So due to that current carrying conductor, placed in the magnetic field, it will experience as a force. So for that current carrying conductor, we need a separate DC voltage source, and for that magnetic flux, creating that magnetic flux, for that current flowing through the magnetic flux, for that current, we need a separate voltage source. So that separate voltage source, here we connected separate voltage source for this current carrying conductor and separate voltage source for this field winding. So such type of motor is called as a separately excited DC motor. Separately excited, because we connected separate voltage source for this, and we connect separate voltage source for this current carrying conductor. So this current flow through the armature conductor. So this is called as the armature current, IA, and this current will flow through this field winding. So this is called as a field winding current, IF, and this is the armature current is called as the IA. This field winding voltage is called as a VF. This is the field winding voltage connected to field winding, and voltage connected to armature is called as a VA, armature voltage. So here this is called as separately excited DC motor. We connected separately voltage source, separate voltage source to run this motor. So next type of DC motor, depending on, now see, there are two windings. One is called as field winding, and second is called as armature winding, because these armature conductors are interconnected actually. These upper conductors and lower conductors are interconnected through the winding. These are the interconnectors, so it will create a winding. So these all armature conductors are interconnected in a winding. So this winding is called as armature winding. So in a motor, there are two types of windings. One is the field winding, and second is the armature winding. Field winding and armature winding. So this is the armature winding, and this is the field winding. So we provided separate voltage source for field winding and separate voltage source for armature winding. So this is a separately excited DC motor. Another type of DC motor is called as a shunt DC motor or parallel DC motor. Shunt DC motor means these two winding, if these two winding connected to one voltage source in parallel, then this is called as a shunt DC motor. Means here, if we connect, instead of separate DC voltage source, if we connect only one DC source, here the same DC voltage source is connected to both winding, then this is called as a shunt DC motor or parallel DC motor. Means same voltage source is connected to armature winding and field winding. Means this armature winding and field windings are connected parallelly. You can see armature winding and field windings are connected parallelly. So this is called as a shunt type DC motor or parallel DC motor. If these two windings are connected in series, then such type of motors are called as a series DC motor. So in this case, how the connections are like that. Instead of that connection, here this field armature, the field winding is connected to like that, is connected to armature winding, and this armature winding is connected to voltage source here. Means these two windings are connected in series. You can see here, this is the disconnected here. So such type of motor is called as series motor, because here you can see due to this voltage source current will flow. So that current will flow through this field winding, upper field winding, then this current will flow through lower field winding. The same amount of current will flow through this armature conductor, and the armature conductor, the current will return here. So this field winding and armature windings are connected in series, because same amount of current will flow through field winding and armature winding. So such type of motors are called as series motor. So these are the main types of motor. Another types of motor is called as compound motor. Compound motor means, compound motor is nothing but compound. Compound means combination of series and parallel. So such types of motor is called as a compound motor. So in the compound motor, we can take this field winding is divided into two parts. One part is connected in series with the armature, and second part is connected in parallel with the armature. So like that, there is a combination of series and shunt. So such type of motor is called as a compound motor. There is a combination of series motor and shunt motor. Means the field winding is connected in series. One part of field winding is connected in series, and second part of field winding is connected in parallel. So such type of motors is called as a compound motor. So DC motor has a 4 or 5 types. First type is a separately excited DC motor. Second type is a shunt motor. Third type is a series motor. Fourth type is a compound motor. And fifth type is a permanent magnet DC motor. So DC motor has a 5 main type of DC motor. So first is a permanent magnet DC motor. Second is the separately excited DC motor. Third is the shunt DC motor. Fourth is the series DC motor, and fifth is the compound DC motor. So these are the 5 main types of DC motor. So compound DC motor is again two types. One is a short shunt compound motor, and second is a long shunt compound motor. So we'll see this in later. So here, so this is the construction of the DC motor. So this DC motor is constructed like that. So here one question is arise here. This is this voltage source. This voltage source is connected is a fixed, but these armatures are rotating. This is a rotating, and this cable or wire is the fixed. So to connect this fixed to this rotating, to connecting this fixed wire to the rotating part, there is one part. This part is called as a commutator, which is a connection, which is connected here, fixed to rotating. So that is the connected actually through the commutator. The fixed part is connected to the rotating part. So always current flowing through the upper conductor is from both side to your side, and current flowing through the lower conductor is from your side to both side. Due to that commutator, this connection is connected to actually brush, and brushes are connected to commutator. Commutator is the one part, the connection. Due to that connection purpose, commutator is used. So brushes are stationary and commutator is rotating. So commutator is like so suppose this is a brush. So brushes are fixed at this position. So these brushes are fixed, and the commutator is rotating. So this is a fix, and there is a another brush at lower end which receives the current. This is the current direction, and here current will return. So there are two brushes. One is at upper position, and second is at lower position. So that the brushes are stationary, but commutator is rotating, and that commutator rotating part is connected to the armature conductor. So rotating part is connected to the armature conductor. So in motor there are, we can see parts of DC motor, So one first part is, this part is called as yoke. This is called as a pole, north pole, south pole. So that north pole, south pole is created temporary due to that field winding, So due to that winding, magnetic field will produce. So that winding is called as field winding. These are called as armature conductors, and the armature conductors are interconnected. So that due to that interconnection, it will create a winding. So that winding is called as armature winding, and the armature winding are placed at one cylindrical drum. So that drum is called as the armature. That total part is called as armature of the motor, and that is the rotating part. So this part is called as the rotor, and this part is called as the stator. So that is the armature conductor. This is the armature winding, and this is the okay. So that is called as the rotating part, rotor, and this is the stationary part. So that this whole assembly, outer assembly is called as stator of the motor, and this inner assembly is called as the rotating part, rotor of the motor. So in between stator and rotor, there is a very less space is provided. Air, very less, below the 1 mm, 1 millimeter, less than the 1 millimeter, or approximately 1 millimeter. There is a distance, gap between stator and rotor. Very less gap is provided, because this is the rotating part, and this is the stationary part, You can see the commutator, working of commutator. In YouTube also you can search animated video, how commutator works. Connected, that motors are connected through the brushes. That due to that brushes, the supply, that armature conductors receive the supply due to that brushes and commutator. So this is the simple construction. So in construction, in parts of DC motors, there are some another part. One is the hook here supporting base. Here the base is there. Here this is called as a base or support. So in outside of the motor, there is a terminal box. So in this terminal box, there are four terminals. 1, 2, 3, 4. So for that 4 terminals, there are 4 names. So for one terminal, there is a name F1. Second terminal, there is a name F2. Third terminal, there is a name A1, and fourth terminal there is a name A2. And there are 4 terminals on the in the terminal box. There are 4 terminals. One is terminal is F1, second is F2, third is A1, and fourth is A2. So these are the 4 terminals inside the terminal box, inside the box. So that box is called as a terminal box. So what it indicates, F1, F2, A1, A2. These are the connections. We can provide the connections to F1, F2, A1, A2. So according to the connections, series or parallel. So any motor, DC motor, we can run as a series motor or a shunt motor, depending on the connections. How we can connect that terminals, how we can connect that field winding terminals and armature winding terminals in series or parallel. So this is it depends. We can run the same motors as a series motor, and same motor we can run as a shunt motor. So it depends how we can connect. So this is the field winding terminals, and these are the second armature winding terminals. Here you can see, here in this case we can see. So this is the suppose field winding terminal 1. So this is called as a field winding first terminal, and field winding last terminal is this. This is field winding last terminal. This is called as F2, and this is called as F1. So this is the armature winding first terminal is called as A1, and this is the armature winding last terminal, second terminal. This is called as A2. A1, A2. So this is the terminal A1, A2, and F1, F2. So in this case, this F1 is connected here in F2, and F2 is connected A1, and again this is connected to A2. Means F1, F2, A1, A2 are connected in series. So such type of motor is called as series motor. So here, according to the supply given to this terminal box, it depends how this motor works in a series type or shunt type. We can change the type of motor. Same motor we can run as a series motor, or we can run as a shunt motor. Same motor, or we can run as a separately excited DC motor. separately. If we provide two voltage source separately, if we connect two voltage source separately to across the F1, F2 and A1, A2, then such type of motor is called as a shunt separately excited DC motor. If we provide separate voltage source for the field winding and armature winding, so such motor is called as a separately excited DC motor. So we can change the type of motor. Same motor we can work as a series motor, shunt motor, or separately excited DC motor. Same motor we can run. So this is a construction of DC motor. So current flowing through field winding is called as a field winding current. Current flowing through armature winding is called as the armature winding current. So see, this is a construction. So next part is the circuit diagram, symbolic representation. How we can represent this motor electrical diagram of this shunt motor and series motor, electrical diagram. How we can show, indicate electrically this DC motor. So we know that in DC motor there are two windings. One is called as a armature winding and second is called as a field winding. So armature winding will indicate like that. So this armature winding is called as a rotating part. It is nothing but a rotating part. So this is the indication for armature winding. And field winding we can indicate like that. So this like that we can indicate field winding. So this is the notation for armature winding and this is the notation for field winding. So if we connect voltage source to the field winding, so this is called as a field winding voltage source, and voltage source connected to armature winding is called as the armature winding voltage. Here two voltage sources are connected. One is the field winding and second voltage source is connected to armature winding. So this is the type of separately excited DC motor. This field is excited by separate voltage source. So this is called as separately excited DC motor. So this is the symbol of separately excited DC motor symbol. So this is a separately excited DC motor. This is the armature of the motor and this is the field winding of the motor. Armature of the motor is called nothing but a rotor of the motor and this is field winding is nothing but stator. This is the rotor, this is stator, or this is called as armature and this is called as field winding. Armature winding, field winding. Notation for armature winding and notation for field winding. So this is symbol of separately excited DC motor. So what is the symbol of shunt DC motor? So in shunt DC motor we can connect. So here in separately DC motor, due to this voltage source, current will flow. So that current is called as a field winding current. And due to this voltage source, armature winding voltage source, amount of current flow through the armature is called as a armature winding current. IA is called as a armature winding current. So here we can see this is the separately connected to voltage source and this armature is also connected separately. So this is called as separately excited DC motor. Another type of DC motor is the shunt DC motor. How we can create that motor in shunt winding parallelly. If we connected instead of separate voltage source, if we connect the same voltage source, to the field winding and armature winding, same voltage source is connected to field winding and armature winding. So such motor is called as a shunt DC motor. Same voltage source is connected to field winding and armature winding. So some amount of current here, current will divide. Some amount of current will go through field winding. So this current is called as a field winding current and some amount of current will go through armature winding. So this is called as a armature winding current. So current will divide. So this is called as a parallel. This field winding and armature winding connected parallelly. So this is called as a parallel connection. These are connected parallelly. So that this is called as a shunt DC motor. So another type of DC motor is a series DC motor. How we can connect this motor in series, field winding and armature winding, how we can connect it in a series. So here we can see if the current flowing, same amount of current will flow through field winding and armature winding, then this is called as a series motor. So here we can connect this motor like that. this motor like that. So here we can see the field winding current, field winding is connected to the armature winding. So here this is called as a series DC motor, series DC motor, series DC motor. So here what is a terminal? Terminal, there are 4 terminals in any motor, there are 4 terminals DC motor. So this is called as a field winding 1 terminal, this is called as a field winding 2nd terminal, this is called as armature winding 1st terminal, and this is called as armature winding 2nd terminal. So here we can see the field winding F1, that field winding F2 is connected to A1 and A2 is connected to negative voltage source. This is the negative and this is a positive voltage source, positive terminal, and this is negative terminal. So such type of motor is called as series motor. If F2 and A1 is short circuited, connected, then such type of motor is called as a series DC motor, series DC motor. So another type of DC motor is short shunt compound motor, short shunt compound motor. So how it looks, short shunt compound motor. If suppose there are 2 parts of field winding, if field winding is connected or divided in 2 parts, suppose. So this is the armature winding of the motor. So suppose the field winding is divided in 2 parts. So this is the 1 part of field winding, and suppose this is the another part of field winding. The field winding is divided into 2 parts. So if suppose 1 part is connected parallel and 1 part is connected in series with the armature winding. So this part is connected in series with this armature winding, and this part is connected in parallel with the armature winding. So such type of motor is called as a compound motor, compound motor. So this type of motor is called as a long shunt compound motor, because shunt is nothing but a parallel. So that shunt part is long with respect to this part of the motor. So this shunt part is longer than the series part. This is the shunt part, a parallel part with respect to this armature. So this is a series. This field winding is series with the armature winding, and this part of the field winding is connected in parallel. So that parallel part is long and series part is a short. As a distance, if we consider distance, this part is a near and this part is a longer to the armature winding. So this is called as a long shunt compound motor, because shunt part is longer than the series part. So this such type of motor is called as a long shunt compound motor, long shunt compound motor. And another type of DC motor, compound motor is a long shunt compound, short shunt compound motor. Short shunt compound motor is like that, short shunt compound motor. The second part of field winding is connected longer than the shunt part. So such type of DC motor, this shunt part is a closer to the armature, and series part is the longer. So this is called as a short. This shunt part is a closer, short. So this is called as short shunt compound motor, short shunt DC compound motor, short shunt DC compound motor. So these are the types of DC motor. So today we see the construction working of the DC motor, parts of the DC motor, and types of the DC motor. So these are the types of DC motor. So this is the symbolic electrical representation, how the field winding and armature windings are connected. So depending on the connections, there are parts of the types of the DC motor, So there are some applications of the DC motor. Actually, the shunt motors are applicable to another some purpose. These are used, and series motors are used for some purpose. So we'll see the applications of DC motor. So applications of DC motor depends on the characteristics of the motor. Actually, there are some characteristics. So these are not in your syllabus, but there are some characteristics. That the characteristics are, there are some famous characteristics are called as a speed torque characteristics, speed versus torque characteristic. If we plot the characteristics of series and shunt DC motor, speed or torque characteristics, suppose this is the torque and suppose this is the speed will indicate by N and torque will indicate by T. So speed torque characteristics of series shunt motor are like that. shunt motor. Speed torque characteristics of shunt motor. If torque increases, speed will reduce slightly speed will reduce if we increase the torque of the DC motor. So this is called as speed torque characteristics, and speed torque characteristics of series motor are like that. So these are the speed torque characteristics of series motor. If we increase the torque, speed of this series motor will reduce drastically. So these are the speed torque characteristics of DC series motor and DC compound motor. So based on that characteristics, there are some applications. So where this series motor is applicable and where the shunt motor is applicable. So there are some applications depending on the characteristics of the DC motor. So that applications I will share with you. So you can read that applications on which purpose which motors are used. So I will provide you that applications. So you can read that application. So this is our today's session. So conclusion of today's session is we seen the DC motor, basic concept of DC motor. First we learn working principle of DC motor. Then we learn the construction of DC motor. In that motor, in that part we see in the parts of DC motor. Then we see the types of DC motor, symbolic representation of DC motor, characteristics of DC motor. It is not in your syllabus. Characteristics of DC motor, and based on that characteristic there are some applications of DC motor. Those series motors are applicable for some purpose, shunt motors are applicable for another purpose. So that these are the applications of the DC motor. So this is our today's topic, DC motor, construction, working principle, types of DC motor and applications of DC motor. So that is the points covered today. So thank you very much